Hello, I'll be presenting our work on identifying human preferred AR visual cues for remote manipulation for different levels of autonomy. Augmented reality helps improve the teleoperator's understanding of robot teleoperation, and one of the objectives of this study is to improve the understanding of optimal AR design choices for varying levels of autonomy. Additionally, we would also like to identify the influence of training on their preferences for AR information and understand how their preferences change as they gain experience with telemanipulation. The experiment was performed on the screen-based setup with the motion of a handheld controller used to control the robot. The experimental task is to remotely manipulate a robotic manipulator to pick up an object and place it in a target box while navigating around the obstacle in the middle of the workspace. There are different control interfaces the participants use in the study to complete the task. The interfaces range across the spectrum of autonomy, ranging from fully manual interface to a supervisory interface. Assisted and shared interfaces have varying levels of human to robot task allocation within this range. Several AR features are provided for various aspects of the telemanipulation task, and the operators can mix and match these AR cues to customize their preferred interface. Motion guidance deals with the information the operator needs to best provide control inputs to control the robot to complete the task while avoiding the obstacle. The IROS feature indicates highly specific local information, displaying the best current direction to move the robot in the operator's workspace to complete the task. Alternatively, global information in the form of path to goal can also be instead preferred, and this feature shows the shortest path to goal while avoiding the obstacle. Operators can choose to be notified about the presence of autonomy via varying levels of saliency. In the order of increasing saliency, it can be in the form of a symbolic light above the end effector, which lights up when autonomy is active, or it can be in the form of text, which appears above the end effector when autonomy is active, or it can be in the form of highlighting the entire screen when autonomy is active. The operators can also choose to know about the intent of autonomy. This information is shown very similar to the way in which information is shown for motion guidance. This is in the form of arrows or path. The arrows or path communicate the intended motion of the robot when in the autonomous state. If the participant choose the same feature for both intent and motion guidance, then the AR feature prioritizes showing information about motion guidance. Information about the obstacle in the way can be detailed in the form of highlighting the face of the box that is most in danger of collision with the robot gripper. Alternatively, the user can also choose to highlight the entire box when they are in danger of collision with it. As for the target, the affordance feature can help with positioning the end effector to grasp or place the target object. This can be done with the help of some color-coded visual hints. Alternatively, in the presence of autonomy, the highlight feature can be used to indicate the target of autonomy. It is to be noted, for any of these individual aspects of telemanipulation, they can choose to not have an AR feature associated with it. At the start of the study, the participants are provided with a demonstration of the control interfaces and visual demonstrations about the behavior of the different AR visual cues. They are then requested to create their preferred visual interface for each control interface based on this understanding. Then the first trial involves participants performing the experimental task with this initial preference. The participants then can choose to make changes to any of these visual interfaces that they have created. In the final set of trials, the participants perform the experimental task for all control interfaces with their altered visual interfaces, and then they perform the trials again with the visual interfaces recommended by the experts. Our findings identify design principles that can be used to design interfaces based on the level of autonomy, with users preferring less AR cues as the level of autonomy increases, with more specific information about robot control and robot motion being preferred with they have higher levels of control, and less information about robot control and more information about the task state with higher levels of autonomy. It is to be noted there was a tendency for initial choice of the participants largely remained similar to their final choices, indicating video instruction and hands-on practice can inform users on their preferred visual assistance, and their final choices tended to be similar to expert recommended interfaces. For future work, we would like to perform evaluation on much more complex tasks and involve haptic cues and study their impact on AR preferences. Thank you. Please find more information about the work being done in our lab in the QR code shown.